So these are the points of inflections here, because you can see from this f of x that here and here the concavity changes, okay? So we'll discuss more with that. So let's try another example, okay? So let's go back to that first example that we kind of saw. Find the points of inflection of f of x 1/3 x cubed plus 2x squared minus 3x minus 10, and determine the concavity, okay? So I'm going to do this in a step of 1 through 4. So follow along with me. What do you think the first step is? You're right. We got to find the derivative and the second derivative. So here's what I got for the derivative. I got x squared plus 4x plus 3. Check the video. Stop the video whenever you have to find the derivative to see that you can get the derivatives that I got, okay? Now the double derivative or second derivative is going to be 2x plus 4. Easy peasy, right? That's our first step, because we're going to need this, right? So let's do our second step now. Second step is for me to see when the second derivative is equal to 0. Why? Because those are our points of inflection, right? Points of inflection. So I got x equals -2. So this is like a critical number, but more than that, it's our point of inflection. It's where concavity changes, okay? So you know what I'm going to do with this point of inflection? I'm going to actually find the full coordinate, right? So I'm going to go f of -2, and you know what I get? I get 4/3. So my point of inflection really is -2 at 4/3. I plugged it into my original f of x, okay? That means at this point of inflection, our graph, you can kind of imagine that there's a concavity switch, okay? All right, now let's go to the third step. Now the third step, what I'm going to do is I'm going to actually take our coordinate here. And are there other critical numbers? Think of other critical numbers. Is there any value that's going to make this guy, we're talking about only concavity, okay? Here, any undefined values from the original f of x? No. So we know our critical number is there, okay? But now let's do our concavity. Let's do our concavity check. It's -2 only, so I'm going to do a -2 here, okay? So I'm going to see where it's positive or negative. If you look in the book, they do a whole table and they do all that. If you want to do it that way, that's okay with me, okay? I'm kind of taking the cheating way, okay? So -2 here, so I'm going to try a -3, and I'm going to try my test values of, I don't know, either 0 or something, okay? So second derivative at -3, what is it? I only care whether it's positive or negative. So I'm going to say it's going to be negative, I'm sorry. This value, it's negative here, okay? And how about second derivative of 0? It's going to be a 4, so it's positive, okay? So I know it's negative here, it's positive in here. And here is our point of inflection. What does that tell us? Let's make a conclusion here. It concave up, concave down. At where? Okay? I'm going to go -infinity. Oh, sorry. Concaves down. Sorry. Concaves up from -2 to infinity, right? Okay? And it concaves down from -infinity to -2. Okay? So, because it's going down here and it's going up here. Okay? Alright. So, we're going to talk about more of the sketches of that later. Okay? Let's do, we already did it. Okay? So, that's our conclusion. So, identify your point of inflection and determine the concavity. Okay? Alright. Let's get to more of the more difficult cases. Okay? So let me show you more pictures of concavity. So I will show you something like this, okay? Now, you can see this. This is a point of inflection, okay? This is our point of inflection. Kind of study those. And point of inflection, okay? First thing you should notice is that our graph, our curve, crosses the tangent line. Do you see that? It crosses it. Okay? Notice that. Because usually our tangent lines only touch the top portion or the bottom portion of each part of the curve. But our point of inflection will always go through the tangent line, crosses the tangent line, okay? Now, okay, so you can see that this is concave up because our tangent lines are down below, right? And this is concave down because our tangent lines are above, right? Kind of think of it that way, okay? Concave downwards because our tangent lines are above, concave upward because our tangent lines are below, okay? All right, find the points of inflection and discuss the concavity of graph of f of x, x to the 4th minus 4x cubed. The first step, always find your derivative and your second derivative, okay? Your first derivative, you should have got something like this. Your second derivative, did you get something like this? Yes, okay? That's our first step. Now let's try to find where our point of inflection is, okay? That's when 0 is equal to f of x, f double prime of x, right? 12x squared minus 24x. So we get, I like to solve it this way so I don't lose any roots, right? Make sure you solve it this way. So you got x equals 0 and x equals 2. So our point of inflections are these 2 points here, okay? All right. Now what are you going to do? You're going to check to see where the intervals that it's concaving up or down. So we're going to check for those points of 0 and 2. And when you try some test values here, I don't know, maybe a -1, maybe a +1, maybe a 3. When you do that, I'll get a positive value here, a negative value here, positive value here. So you can make your conclusion now. Concave up, concave down. Stop the video and write it and see if it matches mine. We're going to sketch all these later, skaters, okay? All right. So let's go to, okay, so now what I'm going to do is, we've been using it, but I'm going to formally introduce you to the second derivative test, okay? Second derivative test says this, okay? Now, let f be a function such that first derivative of c is 0. So we know that. And we know what that means. That's a critical number, right? That's our critical number. And the second derivative of f exists on an open interval containing c. Okay, so second derivative of f exists. It has to exist. Think about what that means, okay? What kind of function doesn't have a second derivative? Okay, think about that. Now, if your second derivative of c is positive, then f of c is a relative minimum. Think about why it's the minimum, though. Think about it. Okay, think about it. And now, what if your second derivative is less than 0 or negative? Then f of c is a relative maximum. Because this guy, it's concaving up, right? Right? Up. So it's a relative minimum when it's concaving up and the second derivative is positive. Now, because this guy means it's concaving down, right? That means it's a relative maximum. So that should make sense, okay? Now, if your second derivative is 0, the test fails, okay? If it's 0, the test fails, okay? Now, but to be honest with you, later we're going to discuss this, okay? F of c equals 0 doesn't necessarily, later, you don't need to know this right now, doesn't necessarily mean that f has an extrema. We're going to discuss that later, okay? But now, okay, so let's finish this. If second derivative of f of c is equal to 0, the test fails. That is, f may have a relative maximum or relative minimum, or neither in such cases, okay? So just understand that, okay? Okay, now, let's go back to here and discuss these images, okay? Now, look at this. This is a graph of function f, okay? And you can see that it's concaving downwards, and f of c is here, and you can see that it's positive, okay? If f prime of c, the first derivative is 0, and f double prime of c, which is the second derivative, is greater than 0, then it's a relative minimum. Okay, don't memorize this. Try to visualize it. If your derivative is 0, because your derivative is 0, right? Your derivative is 0 in this case too. So they both have to have the first derivative as 0, okay? Now, and if your second derivative is negative, that means it's concaving down, right? Because it's going to be negative, concaving down. That means it's the relative maximum. So I don't know. To me, these are kind of opposite. That's how I remember it, okay? All right. Find the relative extrema for this right here. And this guy, I'm sorry to have to cut this off, but it's f of x negative 3x to the 5th plus 5x to the cubic power, okay? All right. Now, let's do the first step. You're right. First step, find the first derivative, right? Next step, find the second derivative. Okay, here's what I got. And here's my second derivative. Okay, is that what you got too? Now what I'm going to do is I'm going to find my critical numbers too, because I need my critical numbers, right? because we told you that we have to make sure that this is equal to 0. Okay, the first derivative. So I'm going to do the second step, which means I'm going to set my f first prime of x equal to 0. So I'm going to do this. Okay, and when I solve this for 0, I get this. Negative 1, 0, and 1. So these are all my critical numbers, okay? Now my next step is what? Oh, you know what, you guys? Let's actually find the coordinates for this, okay? So the coordinates, when I plug them back into f of x, I get this. Negative 1 is negative 2. At 0, I get 0. And 1, I get 2. Okay? Now, these are your f derivatives, right? F prime of x, right? Now let's find, I'm going to go up a little bit, okay? F double prime at c, okay? So that means you got to take these same critical points and go like this. Take double prime of f of negative 1. Take double prime of 0. Take second derivative of 1. I'm using those words interchangeably, and it's okay for you to do that. Now I'm going to do the third step. I'm going to do this one just like your book, where they make a table, okay? Now, apply your second derivative test. So here's your point, right? And here's your sign of, oh, sorry, not sing, okay? Sign, that means positivity or negativity of your f double prime, and your conclusion, okay? What's your point? I got negative 1, negative 2. I had 0 and 0, that's your critical numbers, right? And 1 and 2, remember, these are all the points in which your slope is 0 of your tangent line. Your first derivative, f double prime at negative prime was greater than 0, and f double prime at 0 was equal to 0. Strange case. F double prime at 1 is negative here. So what's our conclusion? That means this guy must be a, think about it, relative minimum, okay? I'm going to skip this one. This one is a relative maximum because, look, its slope is 0 at this point, but this guy is negative. That means concavity is down. Concave's down. That means it's a relative maximum because it's concaving down. And this one's concaving up. Now this guy, remember, this is the case where it's a special case where the test fails. That means it's neither. It neither concaves up or down. Or, it's neither the relative maximum or the minimum. Okay? Alright. So let's go back. Let's try one more example together. Okay? And I'll show you the graph of this function that we just discussed. It looks like this. Okay? And you can see that our conclusion is right. Right? Our x equals negative 1 is our critical number. X equals 0. You can see that how we talked about how the slope is 0, but doesn't mean that it's a maximum or minimum. This guy is a relative maximum, you can see. Okay? Alright. I think I'm going to stop here. We'll do the last example in class when I see you again, okay? Bye!